Section 3.5, Systems with 3 variables. So before we've only been looking at systems with 2 variables, and you're used to seeing that as a graph where the x and the y-axis intersect. So now when we add the z-axis, that is a 3-dimensional graph, and the z-axis is the axis that is coming straight out towards you. Let's look at our first example. So all of these questions with 3 variables for the most part we are going to solve by elimination. Substitution is just going to take way too long and it's going to get really messy. So the part about these problems that get a little confusing is it does take a lot of steps. So you're going to see me label each equation so that way hopefully you don't get lost as we're going through these examples. So I have x minus y plus z equals -1, x plus y plus 3z equals -3, and 2x minus y plus 2z equals 0. Now, it does not matter which variable you choose to eliminate first. However, which variable you choose, you must stick with that and use it with all 3 of your equations. So looking at these 3 equations, I notice I have -y, +y, and I have -y. So it looks like it should be very easy for me to make my y's eliminate. So I am going to start by putting equation 1 with equation 2. The reason I am putting them together is because it has -y and the other one has a +y. So I'm just going to rewrite them right next to each other. And now you are going to eliminate like normal. So I am going to add x plus x, which gives me 2x. The y's cancel out. 3z plus z gives me 4z. And -1 plus -3 gives me -4. So this is now your new 4th equation. Okay? And the good news is it now only has 2 variables in it as opposed to 3. So now, since I use my first and my second equation, I have to do something with my third. So I'm going to start by writing down my third equation. So it's 2x minus y plus 2z equals 0. And like I said earlier, you have to make the exact same variable eliminate. So I have -y, so I need to either pair it with equation 1 or equation 2. And if I pair it with equation 2, that's the easiest to make my y's eliminate. So x plus y plus 3z equals -3. Okay, so again, add 2x plus x gives me 3x. My y's cancel out. 2z plus 3z gives me 5z, and 0 plus -3 is -3. And this is now my 5th equation. So if you notice, in equation 4 and equation 5, they have the exact same variables. They have x's and y's. So now we are going to put equation 4 and 5 together and make another variable eliminate. So equation 4 is 2x plus 4z equals -4, and equation 5 is 3x plus 5z equals -3. So now choose which variable you want to eliminate. So I want to make my x's eliminate, so I'm going to multiply my top equation by 3 and my bottom equation by -2, so that way they will cancel out. So 3 times 2x gives me 6x, 3 times 4z gives me 12z, and 4 times -4 times 3 gives me -12. Now -2 times 3 gives me -6x, which is what I want. I want them to cancel out. -2 times 5z gives me -10z. And -2 times -3 gives me +6. So we add. Z's cancel out. 12z minus 10z gives me 2z. And -12 plus 6 gives me -6. Divide by 2, and z equals -3. So I have one of my variables now, okay? And so I have z equals -3, and I need to look at my 5 equations. I have 1, 2, 3, or 4. Is there an equation that if I plugged in my z value, I could easily get another variable? So I hope that you're noticing that this is just 2x and 4z, this is 3x and 5z. So if you plug z into either equation 4 or equation 5, you're going to be able to solve very quickly for the other variables. So I'm going to use equation 4. It does not matter which one you use, either 4 or 5. So I'm going to plug in my -3 for z, and that gives me 2x minus 12 equals -4. Add 12 to the other side, so 2x equals 8. Divide by 2, and x equals 4. So I have two variables right now. I know my x, I know my z, so I need to solve for y. So again, you're going to look at equations 1, 2, 3, 4, or 5, and you're going to look for one that's going to make it very easy for you to solve for y. So I can't use 4 and I can't use 5 because there is no y variable in them. So I get to use equation 1, 2, or 3. So it doesn't matter which one you use. I'm going to use the second one since y is positive in that problem. So I'm going to plug in 4 for x. I'm going to have my plus y plus 3 times z, which is -3, and then it equals -3. Okay, so 3 times -3 gives me -9. Combine like terms, -9 plus 4 gives me -5. And then I add 5 to -3, and that gives me +2. So I now know that x is 4, y is 2, z is -3. Remember, this is still a point of intersection. It's where 3 planes intersect. So we write it as the point 4, comma 2, comma -3. It's a 3-dimensional point. X, then y, then z. Okay, let's look at example 2 now. So you're going to start by looking at the x's, the y's, and the z's, and you're going to determine which variable you want to make eliminate in all 3. So I notice that this is 2x and 2x, so that's good. I could just multiply by -1 and it would go away. But here's -2y and +2y. I wouldn't even have to multiply by anything to make those eliminate. 3z, -2z, and -z, those have nothing in common. So I am going to choose to start with equation 1 and equation 3 because I notice that if I put them together, automatically my y's will eliminate. So let me rewrite those. So -2y plus 3z equals 12, and then 2x plus 2y minus z equals 4. Okay, so let's start eliminating. So the y's cancel out. That gives me 3x, 3z minus 1z gives me 2z, and 12 plus 4 gives me 16. And remember, this is my equation 4 now. Alright, so I did not use equation 2. I used 1 and 3, so I have to start with 2. So I have 2x minus y minus 2z equals 5, and again I have to make the exact same variable eliminate. So I made the y's eliminate in 1 and 3, and right now all what I have is -y. So I would look at equation 1 and equation 3 to see which one might be the easiest for me to use. I am going to choose to use equation 3 since my y is positive here, okay? So I'm just going to rewrite it. So that gives me 2x plus 2y minus z equals 4. So right now my y's do not eliminate. So I actually need to multiply my equation 2 by 2 to make the y's eliminate. So 2 times 2x gives me 4x. 2 times -y gives me -2y. 2 times negative 2z gives me negative 4z. And 2 times 5 gives me 10. And I'm going to go ahead and I'm going to combine those right now. So 2x plus 4x gives me 6x. The y's cancel out. Negative z minus 4z gives me negative 5z. And 4 plus 10 gives me 14. And this is now my equation 5. So at this point in time, equation 4 and equation 5 should have the exact same variables in it. X, z, and z. So now we are going to put equation 4 with equation 5. So equation 4, I'm just going to rewrite it. 3x plus 2z equals 16. And 6x minus 5z equals 14, okay? And so now you want to look, is there a variable that easily eliminates? And I see that this is positive and this is negative, but I also see that I just would have to multiply my top equation by negative 2, and that would make the x's eliminate. So that's what I'm going to multiply by. Again, if you chose to make the z's eliminate, you're going to get the exact same answer. You would just get x first, and I am going to get z first, so it doesn't matter. So negative 2 times 3 gives me negative 6x. Negative 2 times 2z gives me negative 4z. And negative 2 times 16 gives me negative 32. Okay, so I'm going to eliminate my x's. Negative 5z minus 4z gives me negative 9z. And 14 minus 32 is going to give me negative 18. And look at how nice that is. Divide by negative 9, and you get that z is positive 2. Okay, so now since I have z is 2, I have to plug z into either equation 1, 2, 3, 4, or 5, and I'm hoping to instantly get another variable. So if you notice, equation 1, 2, and 3 still has 3 variables, so just knowing what z is isn't going to give me another one. So you have to choose to plug in your z either into equation 4 or into equation 5. It doesn't matter which one you choose. So I'm going to plug it into equation 4, so that gives me 3x plus 2 times 2 equals 16. 3x plus 4 equals 16. Subtract 4 from 16, and that gives me 12. Divide by 3, and you get that x is 4. I now know what z is, I now know what x is, so I'm going to plug it either into equation 1, 2, or 3 so that I can solve for my y. It doesn't matter which one you choose to plug it into. I am probably going to choose to plug it into this bottom one because x is positive, there's only one z, but again, it doesn't matter, plug it into 1 or 2. So if I plug it into 3, that's going to give me, let me use a different color, so 2 times 4 plus 2y minus 2 equals 4. And I probably chose equation 3 because y was positive, but it doesn't matter. 2 times 4 gives me 8 plus 2y minus 2 equals 4. 8 minus 2 is going to give me 6. Subtract 6 and you get negative 2. Divide by 2 and you find that y equals negative 1. So I know my x, I know my y, I know my z, so now write it as a point because it's where 3 planes are going to intersect. So I have 4, negative 1, 2. Again, make sure you're writing it x, y, and then z. Okay, so something I forgot to mention in example 1 is I could take my answer, x, y, and z. I could plug it into equation 1, equation 2, and equation 3, and it should be true for all 3 of them, okay? So definitely when you take a quiz or a test, you might want to plug your answers back in, and it must make all 3 true, okay? You might get an answer that makes 2 of them true, but not your last one, so it's just a good way to check especially after you do all this work. You don't want to do it all and then find out that it's wrong later on. So like I said in the beginning, you're not going to solve by substitution because it normally makes it really messy. However, if you are given a problem like example 3, it's very easy to solve by substitution. So if you notice, your first equation has x, y, and z. The second equation, however, though, is missing an x. It only has y and z. And look at your last equation. It already is giving you one of your answers. So this is easy. You just take what z equals and you plug it into the equation that only has 2 variables, okay? Because that is going to allow you to easily, very fast, find what your other variable is. So if I plug it into equation 2, so that gives me minus y plus 2 times 2. Equals 8, so 2 times 2 is going to give me positive 4. Subtract 4 from 8 and that gives you 4. And then divide by negative 1 and you get that y equals negative 4. So now I know what z is, I now know what y is, and I'm going to take them both and I'm going to plug it into equation 1 so that I can solve for x. So plus 3 times negative 4 minus, and then z is 2, equals 10. 3 times negative 4 gives me negative 12, minus 2, equals 10. Combine like terms, and that gives me negative 14. Add 14 to the other side, and that's going to give me 24. And then when you divide by 2, you find that x is 12. So now the answer to this problem is 12, negative 4, 2. Remember, x, y, and z. And a problem like this is going to be the only time we use substitution because we can easily get all of our answers.